Wonderful. Thank you again for joining today's webinar. This is the second of our webinar series, and truly appreciate you joining. Today's webinar is titled Getting to Know NexentaEdge, Scale Out SDS for Cloud Native Applications. My name's Don Lopes. I'm moderating today's session and kicking us off. I'm joined by Oscar Wahlberg. Oscar, thank you for joining me here today.
Thank you, Don. Pleasure to be here.
So today we're gonna try to keep this a rather tight, condensed, but informational session. About 30-40 minutes is what we've planned on so far. So we'll see how we do. This is the second, as I mentioned a second ago, of our webinar series. Last Thursday we had our overview session. For those of you that joined us, again, thank you. So the next 3 weeks we're really going to do some deep dives into each of the different products, and we'll talk more about those specific dates and times here in a bit, but thank you again for joining us. Two quick housekeeping items. One, everyone is on mute just to avoid any background noise and keep things clear for our recording for folks that aren't able to join us live but want to listen later in the future. So that's one, as a heads up, and as part of that, please use the chat feature for any questions. I'll be monitoring that, and Oscar will be monitoring that as we go through. We'll incorporate those into our discussion here today as we work through it appropriately. And if not, we've also have some time on the back end to make sure we incorporate everything in. So again, thank you for joining. And with that, let's jump into our session. Real quick, we wanted to just for anybody maybe new to Nexenta, missed last week's session, highlight where we really fit in your enterprise at a, again, a higher level. Reminder, we're a software-defined solution, software only, running on really standard, industry standard hardware. One thing we've really worked on and implemented in our technology in these latest versions is simplifying, and that's simplifying the technology, day in, day out experience. But again, if you're on last week's webinar, we talked a lot about our partnerships and how we build tight reference architectures, configuration guides, testing, post-sales, technical support, all integrated to make the value of software defined there for you while making it easy for you. A key piece to all this is delivering a rich set of enterprise features. Oscar is going to really drill into that today as we talk about NexentaEdge. But the key for us is making sure that as you bring this into your enterprise workloads, we're able to support the features you need and support those areas you're looking to develop. Part of this is we're trying to help you with that cost equation, right? We understand in a lot of organizations, and a lot of what we're going to talk about today for those needs and workloads where you see your capacities growing into petabytes and tens of petabytes, maybe hundreds of petabytes, needing to do this in a cost-effective manner. And so we've really tried to develop our technology and our cost structure and our partnerships to deliver that. Delivering today and tomorrow's needs from an application standpoint, we're going to focus more on the cloud native, or as maybe that describes more of tomorrow's needs, or more the innovation side of the applications. But it's important to understand from an Nexenta differentiation standpoint, we're able to do that for you, but also address traditional workloads. And we'll talk more about that here briefly in a second. And then we want to make it flexible for your business, right? And make sure that you have a single platform to deliver really the workload needs in different configurations, from flash, hybrid, and all disk, fitting your different cost structures, but also fitting your different performance needs. So if we briefly look at the overall portfolio, we've got Nexenta Store, our full-featured SDS for enterprise applications. NexentaEdge, which we're going to spend the core portion of our session here today. A somewhat newer solution that we've had out for about a month or so, Nexenta Cloud, our enterprise NAS for the public cloud. And then Nexenta Fusion, our centralized management for analytics. If we look briefly at how those sort of fit into your overall portfolio or infrastructure, our enterprise applications, things like home directories, virtual machines, backup archive, and maybe some of your tier one storage needs are traditionally, not all the time, but traditionally can be serviced through our product Nexenta Store. We've also expanded that for those needs where you're looking at moving more into a public cloud. We've got our Nexenta cloud technology, leveraging a lot of the core of the Nexenta store to deliver the support need for a public cloud, or those instances where you're leveraging Nexenta store in your private cloud and want to build a hybrid cloud architecture for items like backup, replication, those type of needs. All under a management platform with Nexenta Fusion being our orchestration, management, and analytics of our systems. And then today, we're going to spend a lot of time drilling into our scale-out object file block technology for our cloud-native applications, NexentaEdge. So with that, I know I went through the intro pretty fast, but if you want to learn more, we've got 2 more deep dives on those products. And with that, I want to give Oscar as much time to really drill into today's session. So Oscar, it's all yours.
Thank you, Don. Thank you. So today I wanted to give you all a good overview of NexentaEdge. So my goal today is really to kind of cover the high-level details of the product, use cases, and then move into a quick demonstration of NexentaEdge and kind of give you a rundown of the graphical user interface and some of the functionality. So as Don said, NexentaEdge is really a complementary product to Nexenta Store. NexentaEdge is a product that we started developing here at Nexenta, I guess a little more than 5 years ago now, or at least 5 years ago. Time flies, really. And it's built from scratch at Nexenta. So it's all Nexenta innovation. And really, we started building this product because we saw that there were emerging use cases that were better served by scale-out architectures. Traditional Nexenta Store is a scale-up architecture. NexentaEdge is a scale-out architecture. And what that means is really that you take, a number of x86 servers. So, we start at, essentially 4 servers and with direct attached disk, and you can grow that to many, many servers. I mean, think racks and racks of servers, really. You connect these together using 10 gigabit Ethernet for a storage backend network. And we then form what we call a cluster. Out of this cluster, we can guarantee data resilience, redundancy across disks, servers, racks, and so forth, right? And we share storage out. We share storage out through block, file, or object, right? So block storage through iSCSI, we share NFS file storage today, and we share object through S3 and Swift. So this whole solution is really built to serve a slightly different market than Nexenta Store, right? We built it to start working well, in the hundreds of terabytes, but to scale up to tens and tens of petabytes in a single namespace, like a single coherent namespace that you can share across these different storage types, right? And we started building this because we saw that things like data analytics, large private cloud environments, and so forth were starting to take shape. So we formed this, or we created this storage solution, and we're targeting things like, data analytics, large object archives, data archives, OpenStack environments, Kubernetes, Docker, and all those type of emerging environments. And what we really bring to this is what I tend to call just, enterprise class storage. It's a very broad term in that sense, but what we have created is a scale-out storage system that brings all of the features that you expect out of an enterprise-grade system. Things like guaranteed data integrity, right? We checksum everything that comes into the system so that when you read it back, we know that it's the right data. If it's not the right data, we can self-heal. If a disk goes bad, we self-heal and so forth, right? So all these things that you kind of take for granted, yeah, they're there. We also built in, top-of-the-line data reduction technologies. So everything that you store is compressed, it's deduplicated, and we actually deduplicate across not just a single disk or a single server, but we actually dedupe across the entire cluster, which is very efficient. We also have something that we call quick erasure encoding, which really allows us to do erasure encoding, which is a technology used to reduce the overhead of resilience for data storage. We've made some really innovative choices and then kind of an innovative design in making sure that this is fast. So there's really no performance penalty with what we call quick erasure encoding. So at the top, that's kind of the core of the platform. I know that I already covered a bunch of these items in the first slide, but to me, the core tenets of this product is really the fact that we have very, very strong data integrity. Everything is checksummed. We can always guarantee that the data that you get back and you store in the system is the data that you actually had, right? We can self-heal based on that data. Data reduction technologies, again, very important for addressing those costs. The real cost of actually storing petabytes and petabytes of data. I mean, Don was talking about that earlier, that you're seeing a cost pressure, and that becomes very apparent when you're looking at cold archives, for example, right? When you want to store 10 petabytes of data, and you don't want to store it for just a year, you want to store it for 7 years because that's a regulatory requirement. You know that you're not going to read this data back every day, but you want to make sure that you can store it cost efficiently.
Yeah. Oscar, I think just jumping in real quick, last week we had a slide also talking about some of the use cases of some of the customers with it, and not to get too far ahead of ourselves, but we talked about a university, right, that was doing research,
Yep.
And a large auto manufacturer, right,
Yep.
looking at gathering sensory data, right? So those are kind of two examples of just companies or organizations that are bringing in large amounts of data. They need to do analytics on these data. They don't want to stop growing, right? They're going to keep this for a long period of time. Having that type of functionality around compression deduplication obviously is key to them.
Yeah.
Having a cost structure from a software and hardware standpoint.
Yeah. And that's a good segue going into the next slide, which kind of talks a bit about the use cases that we're targeting with this platform, right? If you kind of look on the right-hand side, you have the traditional object archives, which really means that, hey, I want to store large amounts of data. I want to do it cost efficiently. We can do that in environments supported by all disk, right? So you basically have no SSD or anything like that to accelerate your storage. By using data reduction technologies such as deduplication, compression, quick erasure encoding, you can create a very cost-efficient platform for large, when I say large, I mean petabytes and petabytes of storage, right, that you can store over time. What we also find is that those same architectures serve a different need today. And this is kind of what we talked about, emerging use cases in the sense of analytics. 5 years ago, the analytic platforms were, Hadoop essentially. It was big. We all talked about big data 5 years ago. Today, I would say a lot of that, and the buzzwords have moved into machine learning or AI, et cetera, right? The core tenet is the same thing. I want to store, a couple of petabytes of data, but I want to be able to read it back fast so that I can run a compute job against it, right? And that's where we can use the same platform, but we throw in some SSDs to accelerate this. And that, again, means that we can move in and actually address those use cases. Now, we also serve what more traditionally would be called private cloud environments. Today, it's more, especially if you focus again around containers. I would look at this as, cloud native applications running in container environments. But really what it comes down to is running a lot of virtual machines. Maybe not big virtual machines, but a lot of them, right? It could be through OpenStack, it could be through containers in Docker or Kubernetes environments. We serve these with NexentaEdge, and we can do this really efficiently because of our deduplication and our copy on write technologies. That means that if you spin up, 100 virtual machines or 1,000 virtual machines based on the same image, we only really need to store the deltas between those images, which makes it very, very cost efficient. We tend to serve these environments mostly with all flash configurations, because once you get this mix of various things, all flash is really efficient, especially when you get, deduplication involved as well. So with those high levels, I kind of wanted to drill down into a bit of, the very, very high level architecture. And I'm not going to go too deep on this, but there are a couple of things that are kind of, useful to know and understand. At the top level here, what I have is what I call our services layer. Gateway services, and this is really the translation layer between a protocol that you understand or your application understands, something like NFS or iSCSI or S3 object storage. The service translates this into what NexentaEdge understands. We use our technologies called FlexHash and Replicast to do that. And that's really our data placement algorithms, our data integrity algorithms, our communication protocols on the back end. That's used to disperse the information in a larger cluster, ensure that it gets there fast, efficiently. We store it with guaranteed data integrity. The core back end, we have the technology that we call cloud copy on write. So key value data stored on individual drives. All of this, the whole platform runs on a standard Linux. So think, x86 server, you load your Linux of choice, be it Red Hat, CentOS, or Ubuntu, then you load the NexentaEdge software. The important thing to realize with this is that it gives us a lot of flexibility. That means that we can deploy in a variety of different configurations. The most common kind of, traditional deployments for object storage solutions, for example, would be the dedicated node type deployment, where you have a number of storage servers that are only responsible for storing your data, by providing redundancy for the storage layer. They have disk drives assigned to them, and they have a storage backend network assigned to them. And then in front of those, you have the gateway services, or the object gateway, so to speak, that have both a backend storage connection and a front end or client side facing network. What we can do with NexentaEdge, because we have a flexible architecture, all our services actually run as containers themselves, for example. We can run this in a mixed environment where we run both the gateway service and the storage service on the same node. It gives us a bit more flexibility, and it's, in particular, it's very useful for those smaller environments, where you run all flash configurations. Then you tend to throw a bit more resources at it. You want to keep the footprint a bit smaller. Great way of doing it for that. We also have something that we call container converged. And this is, quite frankly, I'd call it emerging territory in general, but it's really a way to deploy NexentaEdge on physical hardware and run it as a storage platform, serving storage to containers that run on the same physical hardware. So, the 10,000-foot view of describing this would be, hey, it's hyper-converged, but for containers. What it does, it allows you to solve a couple of the problems around the early storage problems around persistent storage for containers. And we'll dig into that in a couple of seconds or a couple of minutes here. But really kind of emerging territory. I see the interest for containers in production environments keep going up and up and up. But I still think that we're some time out before this is something that we see in every enterprise.
Yeah, also real quick, I think we see that in our discussions with our customers, right? We start with an object archive world. It bleeds into a little bit of the virtual workloads, and then, oh, hey, we're also dabbling in containers. Let's see. And again, the value of this platform is having a single management layer, single functionality, learning one technology, and then deploying it for a few different use cases, right?
Yeah, absolutely. I mean, so we actually talked about you mentioned that one of our customers is a large Asian auto manufacturer, right? And they started with NexentaEdge. It's kind of, hey, this is an object-based platform. Yep. Let's start with that. They're now looking at migrating in a very large number of containers into that infrastructure and building their container infrastructure on NexentaEdge. Yep. So they're running essentially object storage. They're running block storage for other workloads, actually tied into their OpenStack environment, and they're now migrating their Docker environments into this. So they have a single platform for all different types of things. So looking real quick at some of the use cases, I wanted to kind of cover these and give you a sense for what we believe is the important parts with each of these use cases. I know that we kind of already covered them in high-level detail. But for object storage, and really, I symbolize this with, both object storage to the traditional cold archives, where, data integrity and cost are really the two most important things, right? what we see is that for the analytic workloads, I mentioned, Hadoop, Apache Spark, any AI, ML type workload today, they have the same tenets. They want to store things cost efficiently because it's petabytes and petabytes of data, but they also want it to be fast, right? So there we see the hybrid use cases come in, but they're using the same type of access methodology most of the time. They're using S3 or what's known as S3A, which is basically extensions to S3. We can actually also provide the same access to the same namespace, the same object namespace through NFS. We have customers that really like that in the sense of I can store, a document or an image or something as an object, but I can also access the same object as a file in an NFS file system. So if you have tools that aren't, object-centric, they can actually still access the data. Allows you to use multiple different types of tools in your tool chain to do the analytics components. It also allows you to migrate old data into a new object ecosystem, right? What's important for these is really, the strong data integrity, the speed at which you can actually read and process the data coming out of the system. And for things like analytics, sometimes it's been very, very useful for customers to be able to do snapshots of the namespace so that they get a known piece of, or a known point in time copy and saying that, hey, this is the layer at which I'm running the analytics. If I take another snapshot, in a couple of days, my data might have updated, and therefore my conclusions of the compute job might change, right? So for OpenStack environments, obviously it's a very different type of ecosystem, and we serve this, as I mentioned, through all flash. Now we can serve it through all kind of hybrid environments as well, but most of the time we see this as kind of, at least we go in and we recommend all flash for high performance workloads. Now, what we do with OpenStack is that we integrate into the ecosystem. OpenStack has a number of integration points that you can leverage. For block storage, for VMs, you integrate through OpenStack Cinder. For, obviously we have drivers for that, and we, use block storage and iSCSI for that driver. We can completely replace OpenStack Swift so that we integrate into the OpenStack ecosystem, providing Swift endpoints. And as such, we can provide image repositories for OpenStack lands, right? Now, what's really important for the overall efficiency of this solution, in my mind at least, is deduplication, compression, and the ability to do snapshots and clones very, very efficiently. Because a lot of the OpenStack environments that we see are built on, cloning off a golden VM or building smaller transient VMs very efficiently. And all of these technologies are ideally suited to do that. So very good success. What we do is we publish all our drivers and everything, and that's all publicly available on our GitHub accounts. So if you go to github.com/Nexenta, you're going to find our Cinder branch, and we push all our drivers there. We obviously push them upstream as well. For a summary of kind of the drivers available for NexentaEdge, you can go to NexentaEdge.io as well.
One quick point too is if there are any Nexenta store customers on the line, we do have drivers available for OpenStack also.
Oh yeah, absolutely, yeah.
We'll cover that in the store, but just as a, it's not just this technology. We've done this across.
Yeah, no. So if you actually go to nexenta.github.io, you're going to hit a driver page for both NexentaEdge and Nexenta Store. And that will contain our, open source drivers for OpenStack, Docker, and various other, Yep. So moving from OpenStack to containers, Kubernetes and Docker. Today we've seen mostly pull from the Docker community, so slightly more enterprise adoption today from what I've seen at least. We have Docker volume drivers for NexentaEdge so that you can integrate with Docker, and essentially, you want to be able to deploy a container and say, hey, I want, a 10 gigabyte storage, persistent storage volume from NexentaEdge. You can do that today. Just a single command line type thing. You get storage, it's persistent storage. What this does, it really solved one of the key problems that the Docker ecosystem had early on. Early on, when you started moving enterprise applications into container ecosystems in general, but Docker in particular, it was really not well suited for persistent storage, right? So when you started moving your MySQL database into it, you could give the MySQL database persistent storage, but it came from the local drive of that server or an NFS file share somewhere, right? So it was a bit cumbersome to point that. And if that host failed, how did you move the container somewhere else and so forth? With NexentaEdge, you can actually solve some of those problems. We can very easily redirect and move the storage around. So as long as you can start the container somewhere else and point it to an NexentaEdge cluster, we have the storage available for you there. And it's, because of our architecture, it's going to be highly available. We're also starting to integrate into Kubernetes. Today, we provide storage to Kubernetes environments through either iSCSI or NFS, through the generic drivers in Kubernetes. But we're also heavily involved with the CSI or the Container Storage Initiative in that sense. So we're developing our own drivers for the CSI project. Right now, it's still pretty early days with the CSI project, but that's how we envision going forward and integrating the Kubernetes going forward. So with that, one final summary slide before we hit the demo. I just kind of, want to give you guys a state of the nation of where we are with the NexentaEdge product. Today, we have NexentaEdge 2.1.3 released. Went GA, I guess about a month ago. So that's the, second generation of this. We've been out, we released the first version probably about 2 years ago now. So we've steadily grown and matured the solution. Today we have a very strong core platform that supports object, file, and block storage with all the built-in functionality that we kind of talked through and enabling the use cases through object archives, analytics, and private cloud infrastructures, right? We also have a very nice GUI built on top of this. We haven't talked so much about that, and that's because I'm going to move into a demo of that in a couple of seconds here. One of the things that the 2.1.3 product also has is support for geo-replication. We've classified this as a technology preview. We do this with functionality that we've developed. It's there, you can test it. It's just not, as polished as we would like it for customer adoption. So we're basically providing early access to the next generation of the product. And that allows us to get strong customer feedback early and, improve the product as we go forward. We did this with NFS, our file support, with the 2.1 version. And we're doing that with what we call the geo-replication right now.
Yeah, I think those type of functionalities are great for those test dev environments where, again, as our customers are getting started and expanding workloads.
Yeah, right. Absolutely. I mean, I think it's a great way for us to kind of, open the kimono, so to speak, and kind of show that, hey, this is what's coming. Yeah. Other than just showing a traditional roadmap slide, actually showing that here's where the rubber meets the road, this is how the functionality is actually going to work. And most of all, for me, from a product management perspective, it allows me to get valuable customer feedback very early in the cycle, and that allows us to create a better and more polished product.
Real quick, Oscar, while you're transitioning into the demo, reminder, folks, there's with all our sort of software technologies, we have the enterprise version, right? So the full-featured technology, perpetual license piece. If you'd like to trial that, it's easy. Just go to our Nexenta.com website, top right corner. There's a trial button there. And we also have a DevOps or, kind of in our community type of world too, for those folks that are looking to just, learn a little bit more, work within your own personal data centers maybe, and tinker in a sense, right? And you can easily, there's another button in the top right-hand corner, community, you can hit that and take advantage of the DevOps edition, or as Oscar mentioned, our NexentaEdge.io directs you right to that also. Yep.
There's even some online kind of try it type things on Nexenta.io or NexentaEdge.io, sorry, that allows you to kind of do that online. Okay, so let's see here if I can move things over to a web browser and do a quick little demo of the NexentaEdge UI. So what I have here running is really, I'm using one of our QA clusters here, so bear with me a bit, but it's running NexentaEdge 2.1.3. It's a 10-node cluster. So as you can see, these main tiles here, you have NexentaEdge, NX16 Edge 101 to 110. These are 10 individual nodes. You can see the various information about individual nodes, high-level CPU information. If you click on these tiles, you're going to get a bit more information about the disks, about the actual statistics, and so forth. You'll get some latency information on the disks and how the general system is doing. At the top level here, this kind of the top level bar is really the high-level status of the system, the cluster status. So things like cluster health, how many nodes do I have online? How many what we call VDAs or virtual devices? In a sense, how many disks are online and how many are supposed to be online. In this case, actually, like all my disks and devices are online, so everything is green. It also shows capacity, so physical and logical capacity. Logical capacity takes things like erasure encoding, deduplication, and so forth into account. So it gives you an estimate of, how much can I get out of this system. Now, my system doesn't get a lot of data reduction because I tend to run all my workloads with incompressible data that doesn't dedupe, because that pushes the system the most, right? So the only data reduction I get here is 1.32x, right? So I get some data reduction, but not a lot. And this is probably due to thin provisioning and things like that, right? Or maybe I've taken snapshots and, whatever. I also see how many services I have and kind of, a general hero number for how many objects do I have in my cluster, right? Obviously, these will move around as I build the cluster and as I have data. Now, if you're keeping your eye out, you can see that I have something called zone 0 up here. And that's really the failure domains that I have these nodes configured in. Now, these nodes are all in a single rack. So I've configured them to be in a single failure domain. If I had multiple racks, I would probably configure them to be in multiple failure domains, and I would see multiple zones and kind of the service in multiple zones. Now, if I move up here, the very, very top orange bar, I have something that's called the cluster namespaces. This is really how we take all the space and divide it into smaller pieces. We have something that we call logical clusters. And within the logical clusters, I carve the space out into what we call tenants. And all of these parts of the namespace are separated. They have different security characteristics. You can set them to authenticate to different ADs or LDAP servers. If I click on this customer A and kind of the settings, I have different settings that kind of get inherited throughout that tenants. I can configure different services or security services for individual tenants. So if I have multiple tenants in my environment, multiple internal customers, or if you're a service provider, multiple external customers. For obvious reasons, I don't want them to authenticate to the same AD because they might not have the same AD, or they might have different types of authentication services. I can control that. Within inside of these, I have what we call buckets, which again is a different namespace separator. Could be seen as a directory in a file structure, for example. Now, if I click on services at the top here, I'm going to see whatever services I have configured within my system. And these are really the gateway services that provide end user or end application services. So in this cluster, I have 2 iSCSI services, I have 2 NFS services, and I have an S3 service running. I also have a service that's called NEdge UI, which is really the GUI that we're using right now. It's running as a Docker container within the cluster. I can configure these. I can obviously create new services by clicking Add Services and so forth, or I can configure and manage these services. If I look at, for example, my NFS Docker service, this is a service that's a part of the integration with my Docker driver that's running on a different service. I can see that I have some options to control the container up here. Those options are going to vary depend on what you can tune there. It's going to vary depending on what service it is. I have a list of gateway nodes here. This is also where I can configure HA for the services and so forth. This particular service isn't HA. It's like you only got a single gateway. but that's because I've configured it that way. I can also at the bottom here see what URLs or where exports are actually NFS exporters here. It looks like I've got about 4 containers defined here, or 4 exports that's sharing storage. If I click out here and look at maybe something a bit more involved in configuration, how about the iSCSI service that's actually an HA service? So the Tempest HA service here, it's an iSCSI service that I generally use to run OpenStack Tempest, or kind of Tempest tests, which is a test suite for OpenStack in that sense. And it's configured as an HA service, as you can see here. I have NexentaEdge 108 and 109 configured to run as a pair. So it's an active-passive failover mechanism with a virtual IP address in the middle. When you configure this is actually a completely wizard-driven process. You can very easily click through it in the GUI. I don't seem to have any LUNs created here, but I could easily do that. And if I look at what I need to do, I need to basically decide where I want to store my LUNs, and how big it is, and set some parameters. I can even rate limit it and say I only want to be able to do 1,000 IOPS to this LUN, for example, right? And then it creates a LUN in the back end. That obviously is going to be a completely thin provisioned LUN. So our system is all copy on write. So again, very efficient that way. So that kind of covers, a single service running on a single gateway, an NFS share, an HA service running on a gateway pair that's being configured as HA. What we can also do is, for example, for things like object services, S3 in this case, because S3 is a stateless protocol, you can involve many more servers, right? So what we do is, like, you can assign, as you see here in the S3 cost bench service, I've actually created a service that shares out a namespace over S3, and I've assigned all of my servers to this. So basically, I run this gateway service on all the servers. That allows me to use something like a load balancer in front to get even more performance out of the cluster and out of the services. And you can see at the bottom here, I actually share a part of my namespace called demo cost bench -1 meg. And that's really just, a part of the namespace. Within that namespace, I can create my buckets, my objects, and so forth. And then just tying it back to the front end here, and so you can see all those enabled services up here. I have 5 enabled services. So that's kind of, a really quick walkthrough of the NexentaEdge GUI. We can obviously do everything that you can do through the GUI, you can do through the command line, you can actually do it through REST APIs as well. So our GUI and our command line is built on our REST-based APIs, the same way we do for Nexenta Store, by the way. This allows us to make sure that, you can actually integrate into your own provisioning systems or your own systems to extract things. We can also feed external analytic tools like Grafana and things like that. We can feed statistics into those systems so that you can create, nice performance dashboards and things like that if you want for more like long-term analytics. Okay.
That's great, Oscar. Appreciate the demonstration. Folks, we got a couple more quick slides just to round up the session here today. Reminder, we're going to move into Q&A probably in the next 60 seconds. So if you do have any questions, please drop them into the questions or chat area of the GoToWebinar.
Okay, excellent. Thank you, Don. I'll see if I can move over to the presentation again, give you some control.
Perfect.
Okay.
Real quick, just more resources that are available for your research and education. As a reminder too, we'll have this recording, you'll have the slides as a follow-up. We've got a nice simple configuration guidelines. So remember, Oscar mentioned earlier in a session, we're running on top of Linux with NexentaEdge, so you have some flexibility across a set number of hardware configurations. But we give you a little bit of definition around what those hardware configurations are. Also network configurations. Right?
Yeah, I think it's a fair point. I didn't cover that so much in detail during the my earlier presentation, but the same way we have an HCL or a hardware compatibility list for Nexenta Store, NexentaEdge have these configuration guidelines. They're not quite as rigid as the traditional hardware compatibility list, but it provides a good starting point for, hey, how do I put together a server that's going to run a hybrid configuration of NexentaEdge? You know, what type of CPU should I use? What chassis? What, you know, how many drives, SSDs? What type of SSDs? All that type of information is shared in there, as well as kind of general guidelines for how do I build my cluster, and what type of networking requirements do I have on the storage network.
Great. Yes, it's a good place to get started as you're looking at building this up or what you currently have and where you need to go. We've also got some white papers from some analysts that we work with, and we've talked a little about the NexentaEdge.io, which is a great resource, spot number of blogs from the team directly, right? So you get a lot of the information and resources right from the NexentaEdge team. Lastly, just a quick plug for the rest of this series. We've got 2 more sessions, same time, same day over the next 2 weeks. So next week we're going to be covering Nexenta Store and Nexenta Fusion, and close our webinar series with Nexenta Cloud on June 7th, that Thursday. So with that, folks, that's the roundup for our discussion here. I'll give folks a couple more seconds here to add any final questions. Oscar, anything closing from your side for the team?
Well, that's a good question. It caught me off guard there. No, I think it's NexentaEdge is right now. It's an interesting time because I've worked within the object storage industry the enterprise storage industry for probably 20 years or so, but I've worked with object storage systems for probably the last, I don't know, 7 or 8 years. And object storage is one of those technologies that, it's coming this year. It's coming this year, but it's a really old technology, right? So it's been on the verge of doing something great for a long time. I think the last year and a half, I've seen a significant uptick in kind of the number of enterprise applications or, applications that we actually use on a daily basis, more or less, that leverage object storage systems. And just the last 6 to 9 months, it's starting to actually ramp a bit more than we've seen in the past. And to me, that's it's indicative of like now there's actually a more of a groundswell kind of applications moving into object storage than has been in the past. Yeah. So with that, I'm super excited to actually have NexentaEdge, and it's that kind of a strong core platform that provides scale-out object storage.
Yeah. And, again, quick plug for the rest of our portfolio. I think the other piece too is if you're looking at changing your infrastructure and looking at maybe addressing some of the flexibility or agility challenges. The great thing is we've got a portfolio of technologies that allow you to take care of your legacy applications, right? Yeah. And move to a software-defined, provide flexibility, gain some of the TCO, perpetual license, all those great things, while introducing technologies like NexentaEdge that may be a little bit more forward-thinking, or things that you're bringing into your environment. And again, we see that within our customer base. We were talking before the webinar, you're off, I think, Sunday to Asia to sit down with another big customer of ours been running petabytes of Nexenta Store, and now are looking at introducing NexentaEdge into their environment and solving some of the challenges we talked about earlier. Yeah, and that's something that it's not uncommon for us to see that a customer has had Store for a long time. They're now starting to look at, hey, I have other applications coming in. Yeah. I need to provide, object storage, for example, right? NexentaEdge is a great fit for that. Great. All right, folks. Not a lot of questions in, so with that, we're going to wrap up today's session. Again, reminder, you'll get an email from us here in the next 24 hours with slides recording, and we'd love to see you again next week, same time, to learn more about what's going on, updates on Nexenta Store and Nexenta Fusion. Thanks again for your time. Oscar, thank you. Have a great rest of your day. Take care. Thank you.